So hello everyone, welcome back to the channel. Today we are going to solve the problem count special numbers. So you are given an array of size n consisting of only positive integers. Your task is to find the count of special numbers in the array, and a number is said to be special number if it is divisible by at least one other element of the array. So let's discuss the question. So we are given something like this array and we have to count the special number within this array. And what is a special number? Special number is a number which is divisible by at least one element in there. So let's say I have the element 4. Now this 4 is divisible by this 2. This 2 can divide this 4. 4 modulo 2 is equals to 0. So I will say, okay, this number is a special number. Now let's come to this 2. This 2 can be divided by this 2. So 2 modulo 2 is equals to 0. This is also special number. Now I come to this. So 2 modulo 2 is equals to 0. This 2 can divide this 2. This is also special number. Similarly, this is not a special number. Why? Because 7 cannot be divided by any of the elements. So not a special number. 6 can be divided by 2. It is a special number. So I can say 1, 2, 3, 4. So count is equals to 4. So answer is equals to 4. That is a special number. Now, let's understand how can we approach this question. Now, first thing, in the normal sieve of Eratosthenes, if you know, let me tell you what is sieve of Eratosthenes. If the number is 2, so I will take all its multiple, not 2 into 1. I will take 2 into 2, 2 into 3, 2 into 4, 2 into 5, and so on, all multiples, and mark them as true, false, you can say anything. That is a flag that will indicate that the number is taken. This is 4. Okay. So the number is taken. So this 2 will mark these 4, 6, 8, 10. That these numbers are not prime numbers. That was the Sieve of Eratosthenes. But let's say if I apply same approach here. So okay. Let's say my array is 2, 2, 4, 6, 8, 10. So I will mark 4 is divisible by 2. So I will mark all its multiple as true, that they are special numbers because they are divisible by someone. Okay. Now again 2 comes. Now again this 2 will mark 4, 6, 8, 10 a special number. Okay, done. Now, but what about 2, 2? This 2 can divide this 2. This 2 can divide this 2. That means I have to also consider the repeating existence of elements because they can divide themselves as well. So, for defining the repeating existence of the elements, we have to take 2 into 1 also into consideration. So, what we do whenever we get a 2, so we will mark itself as well as true. So, why it will help? Why will be marking itself as help? Because let's say I have element 2, and this will mark 2 into 1, 2 into 2, 2 into 3, 2 into 4. So I can say 2's count will become 1. So now again 2 comes. So 2's count will become 2. So this will tell me that 2 is repeating. 2 is repeating 2 times. So if 2 is repeating 2 times, that means more than 2 times or equal to 2 times. That means they can divide between themselves. Okay. And secondly, if I come to 4, 2 will mark 4, count as 1. Also, when the 4 comes, when the time of 4 comes, 4 will mark itself, it will become 2. So we can say our question modified to, instead of checking visited, we have to check whether the count of elements is greater than or equal to 2. If it is, then that means this is a special number. Okay. So you will get the intuition properly. If you didn't get, let's try to dry run the approach. Let's say I come to 2. So I will say it's multiple itself as well and multiples as well. 2 into 1, 2 into 2, 2 into 3, 2 into 4. But we don't need to go to 2 into 4 because maximum number in there is 7. So let's remove this. And now let's take all the elements 2, 4, and 6. So I will say, okay, 2 exists, yes. 4 exists, yes. 6 exists, yes. So I will say, okay, now, now I will mark all elements as true. Okay. Now let's come to 2 again. Let's come to this 2 again. Now if I come to this 2, I will say 2 into 1, 2 into 2, 2 into 3. No need to go ahead because it will exceed the numbers. 2 into 4. So let's mark count as 2, 2, 2. Now, let's go to next two. Now, first check. Now, here we will check that is 2 times already marked. Yes. Yes. But we require only 2 times. So, why to increase the complexity? Why to take extra array? And it will again run through all elements. It will make count as 3, but it is not required. We only want if it is marked 2 times, that means it is a special number. So I will say, let's skip this element and let's go ahead. Let's come to 4. 4's count is 2. So it is already marked 2 times. So let's skip it again. Let's go to 7. Now, 7 count is initially 0. Yes, it is not marked 2 times. Let's mark it as well. Okay. And 7's multiple are 7 into 2, but it is exceeding the maximum element. So we'll say, okay, it is not required. Let's go to next element 3. Now, we can say 3 is 0. 3's count is 0. So we will mark it as 1. And 3's multiple are 3 into 1, 3 into 2. It are 3 and 6, 3 into 3. But it will exceed. Let's skip. So 3 will be 1, 6 will be 3. Okay. Now, let's go to 6. Now, if I go to 6, now we can see 6 count is already 3. So why I want to again visit the same element again if it is marked 3 times? If it is marked 2 times, more than enough. We don't need to mark it again because we want if the count is more than 2, more than or equal to 2, that means it is marked 2 times. So we can say that either two cases can happen. If they are same number, then 2 will mark itself 1. If it will mark itself so 2, so that means number are repeating, they will divide between themselves. So this is right. Second case can arise. Let's say if 2 will mark 4. Okay, so 4 will mark one time, and when I come to 4, 4 will mark itself, so it will be 2. So we can say that count is 2. Okay, so this number is divisible by someone because 4 will mark itself always. 4 count will be 1, but 2 will also come and mark it. So that means count is 2. So if count is 2 anytime, if count is 2 anytime, that means it is a number which is a special number. So now let's try to code up this approach. So what was the approach? So basically we have taken the maximum element. Now maximum element array dot begin, array dot end. Now, why we take the maximum element? Because every time the loop, whenever I have taken the element 2 into 1, 2 into 2, 2 into 3, so I have to check that till how much time I have to run. So since maximum element is 7, so I am exceeding. Just break here. No need to go ahead. So we will say, okay, that means maximum element is required. Now we will create another map to store the frequencies. Another map in NP. And then let's make the count variable as 0. Now I will take every element as I was taking, and the element is array of I. Now I will check if MP of element is less than 2. If it is marked, if it is marked less than 2 times, 0 time, 1 time. If it is marked less than 2 times, that means we have to mark it to check whether the element is repeating or the element is marked by someone and marked by itself. So that means if the count will become 2, that means it is a special number. So I will say, okay, 4 and j is equals to element. As we do in Sieve of Eratosthenes, for every multiple, I will do j plus is equals to element. So let's say I am at 2. Let's say my number is 2. So I will do 2 to it, 2 to it, 2 to it. And we will get 4, 6, 8. Okay. In this way, we are getting the multiples. That's why I was adding element and I'm going until max C because it's not required to go ahead elements and increase the complexity. Now, every time when I go to next element, I will make the map of J plus plus that these are special numbers. Okay. Now, what do we do? Now, we will go to every element and check. Let's say element is array of I. We will check if MP of element is greater than 1, that means it is marked more than one time. That means it is marked two time, three time, four time, any time. We can say it is a special number. We will do count plus plus and at the end return the count as it is. So let's try to compile and run the code. It should be max element. It is a STL function. If you don't know, simple STL function which gives the maximum element from array. Let's try to compile and run the code again. Yes, so let's submit the code. Okay, so the question is totally working fine. So the total intuition behind this question was to modify the sieve of Eratosthenes. Instead of marking the element others, we will mark the element itself as well. So if we mark itself as well, let's say 2 will mark 1. Let's say 2 will mark itself as 1. Now 2 will again mark itself. So its count will become 2. That means 2 is appearing more than 2 times, more than equal to 2 times. So we can say yes, it can divide between themselves. So that's why to check the existence of 2's as well, 3's as well, any number as well, smallest multiple within the array as well, we have to take the itself element as well. Okay. So if you like the explanation, please like, share, and subscribe to my channel. Thank you and have a nice day.